Today, I want to walk you through what Claude Code can do, and more importantly, why it fundamentally stands apart from every other AI coding tool you've seen so far. This is not about autocomplete. This is not about writing snippets faster. Claude Code represents a shift from AI as a helper to AI as an execution system. When you understand its capabilities, architecture, memory model, and workflows, you'll realize this is less of a developer tool and more of an autonomous engineering layer. That distinction is critical, especially as software systems continue to scale in complexity. Hi, I am ཙ𝘂𝘁𝗄𝗃, founder of School of AI. At its core, Claude Code combines multiple advanced capabilities into a single execution environment. It generates agentic code, meaning it understands intent and acts across multiple steps. It reasons deeply across large contexts, debugs intelligently, and applies fixes deterministically. It operates natively with Git, supports parallel subagents, and includes auto checkpointing for recovery. With massive context windows and MCP-based tool integrations, Claude Code can plan, execute, test, and deploy workflows that would normally require coordinated human teams. This isn't just speed, it's scope. Let's talk architecture. Claude Code follows an agentic execution model. Everything begins with user intent, not instructions, but outcomes. A planner agent decomposes that intent into structured tasks. Subagents execute those tasks in parallel. Tools are invoked directly. Codebases are modified. Tests are generated and run, and deployments can be triggered. This architecture mirrors how elite engineering teams operate, except it collapses planning, execution, and coordination into a single intelligent loop. The execution flow is deliberate and structured. Intent becomes a plan. Plans become subtasks. Subtasks trigger tool calls. Tool calls result in real code changes. Those changes are validated through tests and finally deployed. Importantly, this is not a linear script. It's a feedback loop. Claude observes outcomes, adapts execution, and continues until the objective is met. That's what makes this autonomous rather than reactive. One of the most powerful features is persistent project memory, implemented through 𝘂𝘁𝘂𝗏. This file acts as long-term memory for the AI. It stores architectural decisions, conventions, commands, and historical context. Instead of re-explaining your project every session, Claude starts already aligned. This single feature dramatically reduces cognitive overhead and enables consistency across long-running projects, something chat-based tools fundamentally cannot do. Persistent memory changes the game. It allows Claude to reason across sessions, maintain architectural integrity, and avoid repeating mistakes. Over time, the AI behaves less like a stateless assistant and more like a deeply onboarded team member. This leads to fewer errors, faster execution, and much higher trust in automation. Long horizon work, refactors, migrations, system redesigns becomes practical instead of risky. Claude Code's differentiators are structural, not cosmetic. It is terminal native, meaning it operates where real engineering work happens. Its edits are deterministic and span multiple files safely. It reasons across entire codebases, not fragments. It supports long horizon workflows and maintains state across sessions. And crucially, it uses tools directly instead of relying on fragile prompt chains. This is execution-first AI. When you compare AI coding tools, these are the dimensions that actually matter: agentic execution, persistent memory, multi-file refactoring, parallel agents, native terminal access, context length, and CI/CD automation. Most tools excel in one or two of these areas. Claude Code covers all of them, and that completeness is what enables autonomy instead of assistance. Compared to other popular tools, Claude Code offers full agentic execution rather than partial automation. It maintains persistent project memory. It handles true multi-file refactors and parallel agents. It operates natively in the terminal and Git, and it supports very large context windows. This isn't an incremental improvement. It's a different category of tool altogether. These capabilities unlock serious engineering use cases. Large-scale refactors across monorepos, greenfield system builds from intent to deployment, navigating and modernizing legacy codebases, automated code reviews at scale, generating and maintaining test suites, creating stack-wide pull requests, automating incident hotfixes, and continuously modernizing systems without stopping delivery. This is where AI stops being experimental and starts being operational. Claude Code excels where complexity compounds. Large repositories, long-running tasks, multi-step execution, high-risk refactoring, system-level automation. Anywhere coordination overhead dominates human productivity, Claude Code shines. It doesn't replace engineers. It removes the friction that slows great engineers down. This is the philosophical shift. We are moving from tools that autocomplete code to systems that execute software development. Claude Code is not a better IDE feature. It is an autonomous system actor. Once you adopt this mindset, you stop thinking in prompts and start thinking in outcomes. That's the future of engineering. Claude Code runs where modern work happens, across macOS, Windows, and Linux, inside IDEs and terminals, in local environments and cloud platforms, integrated with collaboration tools. This ubiquity matters because execution power is only useful if it fits seamlessly into real workflows. Let me leave you with this. We are witnessing a transition from AI that suggests to AI that executes, from autocomplete to autonomous software execution. Claude Code represents that shift clearly and practically. The teams and individuals who learn to work with systems like this, not just use them, will define the next decade of software engineering. This isn't the end of human creativity. It's the removal of unnecessary friction so creativity can scale.